Today we are on Unit 12, Lesson 3, Part 2. We'll be covering pages 410 to 413. Be helpful if you had 3 colored pencils or pens and a calculator. Sometimes when we're working with data and probabilities, it's helpful to use what we call a hypothetical 1,000 two-way table. That's where we let 1,000 be the total in our population. We have this scenario where a survey was performed on a Milwaukee high school asking students certain questions. Based on the survey, the probability of a randomly selected student at the high school having asthma was 0.193. The probability of a randomly selected student having at least one member in their household who smoked was 0.421. It'd be easy to calculate the probabilities if the data had been organized in a two-way table like the one on the previous page, exercise number 6. But there's no table here, only the probabilities. So we're going to set up what is called a hypothetical 1,000 two-way table. Place the value of 1,000 in the cell representing the total population. So here it is. The total population is 1,000. Based on the hypothetical 1,000 population, consider the following table. Students indicate he or she has asthma, does not have asthma, not A. No household member smokes, not S. At least one household member smokes, S. The probability that a randomly selected student at this high school has asthma is 0.193. This probability can be used to calculate the value of one of the cells in the table. So the probability has asthma, that would be for cell 3. Cell 3 is connected to this probability. Calculate the value of the cell. 0.193 times 1,000 would be 193. So out of 1,000 students, 193 have asthma. The probability that a randomly selected student has at least one household member who smokes is 0.421. At least one household member who smokes. Which cell is connected to this probability? Cell 8. The value of this cell, 0.421 times 1,000 is 421. In addition to the previously given probabilities, the probability that a randomly selected student has at least one household member who smokes and has asthma. So S and A, that would be cell 2. And the value there would be 120. Let's complete the two-way table by calculating the other values. Okay, so 73 plus 120 would bring me to 193. 120 plus 301 would bring me to 421. Cell 7, 421 plus what would give me 1,000? 579. 73 plus 576 would bring us to 479, and over here 7 would be 200, so 807. Looks good. Oh, I guess yep, let's go back and correct it. This one would be 506. Based on our completed two-way table, estimate the following probabilities as a fraction and also as a decimal rounded to 3 decimal places. Our randomly selected student has asthma. Okay, so a student has asthma. We're looking here. What is the probability this student has at least one household member who smokes? So looking at our students who have asthma, probability has at least one household member who smokes. That is 120 out of the 193. 120 over 193. Calculator. Do 3 decimal places. 0.6213. Nope, 0.622 rather. A randomly selected student does not have asthma. So we're looking at students that do not have asthma. So we're looking at this row. What is the probability that he or she has at least one household member who smokes? At least one household member, 301 out of the 807. .373. A randomly selected student has at least one household member who smokes. At least one household member who smokes. We're looking at this column here. Our denominator of our probability will be 421. So out of those 421, what is the probability the student has asthma? How many have asthma? Has asthma, 120. 120 divided by 421. 0.285. Do you think that whether or not a student has asthma is related to whether or not this student has at least one family member who smokes? We are actually going to come back to this after our next lesson. This notation is, this vertical segment means given. Probability of asthma given, just write that out in words. Probability of A given S. Our next exercise. Suppose the following information is known about Kingston High School. 40% of students are involved in one or more of the after-school athletic programs offered at the school. It's also known that 58% of students are female. The athletic director indicated that 23.2% of the students at Kingston are females and participating in after-school athletics. The students decide to construct a hypothetical 1,000 two-way table to organize the data. Okay, after-school athletics program, going to use A to represent that, and do not participate, not A. So 1,000 is our total. 40% of students are involved in one or more after-school athletics. One or more after-school athletics. 40% of 1,000 would be 400. So that means right here, this would be 600, because 400 plus 600 is 1,000. It's known that 58% of the students are female. 58% of 1,000 is 580. Plus 20 will bring me to 600, so 420 are not female or males. 23.2% are females and participate. So females and participate. Be 232. do not participate, females that do not participate, 580 subtract 232, let's see, 348, and 232 plus 8 gives me 240, 300, so 168. Just filling in the other cells here. And 350, so 252. So the completed hypothetical 1000 organizes the information. It makes it a little easier to answer various questions. Consider the following events. Let F represent the event a randomly selected student is female. A represent the event a randomly selected student participates in after-school athletic program. Based on the descriptions above, describe the following events in words. Not F is going to be males or students that do not participate in after-school athletic programs. So not F or not A would be males or students not participating in after-school athletics. F and not A, that's females, and not participating. In athletics. Here's the completed table. Hopefully I was correct on the other side. Yes, looks good. Based on the above table, determine the probability of each of the following events. Probability of F. Female, that's 580 over 1,000. I'll leave it as that fraction. You don't need to reduce. You can if you want, or you can write it as a decimal or a percent. Probability athletic program. 400 over 1,000. Probability not female. 420 over 1,000. Probability not A. 600 over 1,000. Probability of female and athletic. F and A, 232 over 1,000. Probability of F or A. Remember, let's use our formula. Probability of F or A is going to equal the probability of F plus the probability of A minus the probability of F and A. Probability of F is here, 580 over 1,000. The probability of A, 400 over 1,000. And the probability of F and A is 232. Which is equal to 980 minus 232, 748 over 1,000. Determine the following values. The probability of F plus the probability of not F. Okay, F plus not F. Probability of F plus not F. 580 over 1,000 plus 420 over 1,000 equals 1,000 over 1,000. Sorry about that. It's 580 over 1,000 plus 420 over 1,000 equals 1,000 over 1,000, which is 1. The probability of A plus the probability of not A. Probability of A is up in B, that's 400 over 1,000, plus the probability of not A is 600 over 1,000, which is 1,000 over 1,000, equivalent to 1. What do we notice about the results of part A and B of number 3 here? The sum equals 1. And this is the probability of A, and then the probability of not A is its complement. So in general, the probability of an event plus the probability of the event complement would equal 1. Thank you for your attention.